Okay, sounds like recording is in progress. Perfect. All right. So let's go ahead and do some naming compound stuff. So the first one, a lot of this requires memorization. So like knowing what NH4 is, that's just gonna go down to just making some flashcards and memorizing that. So NH4 is what we call the ammonium cation. So it has a +1 charge on it. And do we all know the charge? Because I can't see the chat, so it would be nice if y'all could just unmute and put it in the chat, say it. So like, do we know what the charge on chloride is right here? Yes, no. I can't see the chat, so if you just wanted to speak up. Anyone? What's the charge? My question is what's the well, that's the charge on ammonium right here. But what's the charge on the Cl here? -1. Yeah, so someone in the class is helping me out here. So it said -1. So we have ammonium and we have chlorine. When chlorine is in its ionic state, it's not called chlorine anymore. It's called chloride. So the way you would name this is just ammonium chloride. Just like that. All right. Are y'all able to hear? Like, is anyone talking? Okay, so okay. I wasn't sure if like my audio is messed up where I can't hear. Alrighty. So yeah, just feel free to unmute at any time. People, students, friends. So that way, because I can't see the chat. So let's go move to the next one. Here we have FeNO3. If we do our reverse crisscross, we know that the 3 will go to the iron. Oh, well, I already told you what that is. And the 1 goes up here. So you get a -1 there. So it would look like, those look like this. NO3 -1. So we know this is iron now. What is something we have to keep in mind when we're naming this compound? If it's an ionic compound, because it's 2 ions, what do we have to keep in mind about iron? What do we need to include with it in the name? Say it. The Roman numerals, right? To designate what charge it is. So iron, and it has a +3 charge, so this is iron 3. And NO3 -1 is what? Say it. Perfect. Yeah. So nitrate. So iron 3 nitrate is the name of this one. And again, this just goes down to memorizing like what NO3- is versus something like NO2-. Know the difference between these two, right? This one's nitrite, this one's nitrate. Important. For this one here, we know that the 3 goes up here, so you get titanium, Ti with the 3+, and then this 1 goes up there, so you get Br-. What's the name of this one? Anyone? Just yeah. You said titanium 3? Yeah. Yeah. So it's titanium, and because we realize that titanium is a transition metal and it can have multiple charges, we have to designate which charge it is. So in this case, it's titanium 3, and then we just put the anion, so bromide. So for ionic compounds, for at least your halogen, so like Br chlorine and iodine, the ending turns into IDE. So bromine turns into bromide. So that's why you changed it up. You wouldn't put bromine here. Okay. Next one. Anyone on Zoom that's not in the classroom with me want to unmute and tell me what the name of this one is and maybe how the step-by-step process on how you arrived at that name.
I have a statement.
This guy.
Press
Go ahead
just
and
in
talk.
chat, press the Alt key and H together. Alt plus H.
Who are you talking to?
Hmm?
Who are you talking to?
You press the Alt key and H to see the
Dude,
chat.
I'm on my iPad, man.
Oh, my bad. Never mind.
This guy. Let's see. Maybe I can just go here. Or maybe you can read out the chats to me, Rish, if you want to do that. Crazy world we live in. Okay. Sounds like a plan. So anyone in the room now want to help me out on what the name of this one is? Copper. So copper. So we get Cu plus 1, phosphorus 3 minus. So we have to be specific in which copper it is, right? So it is copper phosphide, but it's a specific one. Which one? Copper 1, right? So we'd do copper, Roman numeral 1, and then phosphide, not phosphorus. Okay. Anyone want to go ahead and tell me what the next one is? This one? That is a good talk. Okay. So the interesting about tin is that it's not a transition metal, but it can have multiple charges. It's a weird one. So yes, tin can be a +2 or a +4 charge. So in this case, it's +4. And what did you say was the last part? It is selenium, but if you're writing it, what would it be? Selenide. Yeah, something like that. Selenide. So just like spelled like that. How did she know the tin was a +4 charge is a good one. So we know if you do this, you get a 2 plus there, and the 1 here goes to a -1. That gives us these two. So we get 10 plus 2, selenium -1. But the thing we know about selenium is that it is right underneath sulfur on the periodic table. So that should be right. So looking at our periodic table, you have oxygen, sulfur, selenium, and if it's a main group element, then it has a fixed charge. So if it's in the same group as oxygen, that means it has a charge. It should have a charge of -2. But as we see here, the charge of selenium is not -2, it's -1, which means that we need to get it to -2, you need to multiply the charges by 2. So this actually tells us that we have tin with the 4 plus because we multiplied 2 times 2, and then selenium with our 2 minus charge, which is what it should be, right? So now that's how we figured out it was tin 4 and not tin 2, because if you just did the regular reverse crisscross, you would get tin 2, but that's not the right charge because selenium would have a -1 charge, which we know it has a -2 charge and not a -1. Is there any questions on that? I'm going to go over here so I can see. Oops, sorry, I don't want to do that. Let me see. Over here. I'm looking at my chat now, so Let me know if there's any questions on that, or if there's no questions, just say good to go, or say nothing. Well, say no questions. Perfect. Does that make sense to everyone? Good to go. Nice. Perfect. All right. This is a nice one. Interesting one. So looking at this, you would get charges of gallium +1. Well, I just told you what that one was, and AS -1. Let's make sure, let's see if those are correct. I'm pretty sure this one should have a minus. No, I don't want to be wrong. Yeah, -3. It's right under nitrogen. Therefore, if it doesn't have a -3 like it should, what should we do? Say it high, loud with pride. Multiply it by 3, so that way we get the right charge on AS. So now you get GA plus 3 AS -3. And where's gallium on the periodic table? Well, gallium is right here, right 2 underneath boron. If it's not a transition metal and it's not lead or tin, does it need a Roman numeral? No, right? So this would just be gallium. And what's the last one here? How would you? It is arsenic, but arsenide, right? Let's see if I can spell that. Arsenide. Is that right? Arsenic. Arsenide. Perfect. How are we doing on that one? Does that one make sense? Cool. Let's see. What do we do next? The next one is dealing with a couple. Next few are actually dealing with polyatomic ions. So again, this goes back to memorization. What is? Let's go ahead and move this back up here. We get a 2+ on that. We move this up here. So we get Pb 2+ SO4 -1. So is that okay so far? Is this okay? We can start naming it. No. Why no? Uh-huh. Yeah. So someone in the room just said that sulfate always has a -2 charge, right? Or 2- charge. It right now it says that it has a -1 charge. We know that's not right. So we need to do our multiplication thing. So 2, Pb 4+ and sulfur or sulfate 2- that. Next we can name it. So lead is not a transition metal, but it is one of the it's in a group called the post transition metals. So it can have like different charges, and it does have it has 2 charges, a +2 and a +4. In this case, we're dealing with lead 4, and we have sulfate on the end. For this class, and at least in this country, you should not be writing sulfate like this. Okay, I don't know where some people get that, but sulfate is with an F and not a PH. Deal? Deal. Okay. Someone walk me through this. Someone. Hey, Rish, I don't know if you want to maybe join on your iPad, so that way after this section, I can let you do these sections here, if that's something you'd want to do. If not, I'll be happy to do all of it. Okay, that's nice. Anyways, What would we do for the number 8? Yeah, so we can do our little reverse crisscross is like what I like to say. So the 2 goes up here. I'll do it the way y'all always see me do it. So that goes there to give us Be2 plus, and this 1 goes up here. So it gives us HCO3 minus. Now we know beryllium. Well, I just told you that again. So we know Be from the periodic table should have a +2 charge because it's the first element on group 2. It has the atomic number of 4. Therefore, all the charges look good. So we can start naming it. Do we need a beryllium is a metal, so we should have a Roman numeral charge on it, right? No, is the right answer, just as someone said in class. That's because it's a main group element and it always has a fixed charge. So we can just say, please give me some slack if I spell this wrong. Berry. Obery. Is that what I did? Yeah. Looks like I got my money out. Okay. And then this is a polyatomic ion. So we know over here. Do y'all know what this is? So this is carbonate. When you add a H, you're actually adding an H plus when you add a H to it. So if you add an H plus, you change the overall charge because a +1 and a -2 goes to a -1 charge. So HCO3 -1. Do we know the chart? Do we know the name of this one? Yeah, so bicarbonate is what I would go with. Now we can just put that in our name. So beryllium bicarbonate. Perfect. Any questions on there? Let me go ahead and see if what I've been missing in the chat. Yeah. So someone in the classroom said, why did I not put Roman numerals for beryllium? So looking at a periodic table, everything, let's see if I can, let me stop screen sharing so I can get a periodic table that I can kind of hover over so you can see what I'm talking about. Just give me 1 second. Periodic table. And let's do that. About 15 more seconds, guys. Photo library, all photos. There, bad. Perfect. And 5 more seconds. Share content. 3, 2, 1. Okay, I'm back. So looking at the periodic table, beryllium is right here in the main group. So all these are main groups. So group 1, group 2, and this is our third main group, 4th, 5th, 6th, 7th, 8th. Most main group elements, except for like tin and lead, which is in this series of post-transition metals, have a fixed charge. So everything in group 1 is going to have a +1 charge. Everything in group 2 is going to have a +2 charge, and so on. So because group 2 is a main group element, it only has 1 charge, so beryllium can only have a +2 charge. Therefore, there is no need for a Roman numeral. We only use Roman numerals for things that can have multiple charges. So those are our transition metals, probably some of these metals down here, and some of our post-transition metals that we deal with. Does that answer your question? Cool. Yep. So next thing we have here is this thing will go up there. So and this 3 will go up there. So you get Mn3 plus SO3 2 minus. We know Mn is, let's see, where is it? Mn is in the transition metal series, so it probably can have more than one charge, especially since it's not one of the ones that has a fixed charge, which is zinc, cadmium, silver, and scandium. So we know we need to use a Roman numeral. Now, to figure out if it's the correct charge, we have to look at this polyatomic anion. What is the name of this one? So that one's sulfite, and we know sulfite should have a charge of what? 2 minus, right? So sulfite should have a charge of 2 minus, and look, after a reverse crisscross, it has a charge of 2 minus, which means all the charges are perfect. That means this one has a 3 plus charge. We don't need to do any multiplying like we did up here. We can just write the name out. So you won't be able to look at a periodic table, so you won't be able to see names like this, but you should know after spending a lot of time with chemistry that Mn stands for manganese. Manganese in this case has a charge of 3. Oh, we don't do that. We do Roman numerals. 3 plus, and we indicate that with Roman numerals, and it's paired up with the polyatomic ion sulfite, not sulfate. So sulfite. That was bad. Sorry. Deal. All right, last one, and maybe if Rish has joined with his iPad, he could do the next one. If not, you'll be stuck with me. All right, so this goes up there. That goes up there. We have Al 3 plus Cn minus. Now, what's the name of this? Wait. Okay, so Cn minus is cyanide, so that's a good place. Oh my gosh, I just got news that Rish is in the shower, so it looks like I'm gonna be doing the next few problems. This guy, Rich. Okay, and what's this one here? Aluminum. Do we need to indicate charge for aluminum? No, we do not. And that's because it's in a main group and it's not one of those exceptions like tin and lead. So it's in a main group, it always has a +3 charge. Therefore, if you did this, you would be wrong. If you did this, you would be right. Let's see if anything is in the chat. Yeah, perfect. Aluminum cyanide. Okay, is there any questions on that one? You can put no in the chat. And if Rich is here, if he took his shower, then maybe we could let him do the rest. No questions? Rich, are you here? Perfect.
Oh yeah, my microphone was off. I'm here.
Okay. All right, I'll go ahead and mute myself and stop screen sharing, which looks like you already got that done. Hey, Rich, go back to your groupme. I want to see who you're texting.
Oh my god. This guy about to put my whole text history on blast, bro. Give me 1 second, guys. I forgot that GroupMe on an iPad or iPhone is absolute garbage. So yeah, I'm gonna download the stuff and then we can get started. right? If we do that over here. Oh, this import a new document here. Stop share. Again. What the? Right, share screen. Start broadcast. All right, almost there. Almost got the technical difficulty sorted. All right, technology rules. Okay, write the formulas for the following compounds. Chromium 6 phosphate. Well, what are we thinking? What's our first step? Let's go to Zoom people first, because that's easier to see on my end. Excellent. All right, so somebody already came up with the answer. So that's CrPO42. See if you're right. So chromium, right, with this 6 right here, tells us that it has a +6 charge. So +6. And then phosphate, right, as our polyatomic ion. So our PO4 3 minus. Go ahead, right, do the whole switch, loop to loop, crisscross, whatever the heck you want to call it. So this is PO4 3 minus. That goes here. This goes there. I learned it as a loop to loop. It's actually fun that way. Sorry, that's a 6, not a 4. 6 plus. And then you get CR3, PO4, 6. We got to reduce this down because ionic compounds like to be in their empirical formula at all times. You have to reduce them to the lowest terms. So it's CR, PO4, 2. CR, PO4, 2. And that's our answer for that one. So questions about any of that? Fantastic. All right, so vanadium 4 carbonate. We do the same thing basically. So what charge will our vanadium have that it has that 4 on it? +4. Oh wait, so somebody said +4. So +4. And then carbonate, right? That's our polyatomic ion. It's got that charge of CO3 2 minus. So vanadium, right? The chemical symbol, believe it or not, is V. And then carbonate, right? Our polyatomic ion, CO3. And then we have our 4, 2. So we'll go ahead, cross, loop to loop, whatever you want to call it. Get V2, CO3, 4. But once again, we got to reduce to our lowest terms. So this reduces again. So it's V, CO3, 2. That's what we got here. VCO3, 2. All right, any questions? Or are y'all pros at this already? Yeah, I can tell. Y'all pretty much pros already.
Yeah, I think we're all pros.
Yeah. Professionals. Oh, Kennedy's saying she's a pro. So, all right. If y'all are pros, then pick one that looks difficult and we'll do that one. Anyone on the list? Anyone that's like, I have no clue how to answer this. All right, we got a 28. 28. So this is ZN3P2. So this, right, you got to work backwards. Use that reverse crisscross. I don't like the crisscross personally. It's like you're not crossing anything. I like to do the loop to loop. It's more fun. Like the SpongeBob thing, you loop to loop and pull. Your shoes are looking cool. That one. All right. Anyway, so zinc, right? So the 2 over here is on the phosphorus. And since you switch the subscripts, no matter what you call it, the loop to loop, that the 2 over here must have came from the zinc. And then right the 3 right here. So this 3 must have come from the phosphorus. So you got to switch these up. And this, right, we got to write the formulas. It's already okay. So so it means like write the formula and then give the name, whatever. So this one you'd actually give the name, not write the formula. I know that's kind of confusing, but yeah, the 3 must have come from the phosphorus and the 2 must have come from the zinc. So the way we solve it out, we get zinc phosphide. That'd be the name of that. Why didn't I include a Roman numeral right here for zinc? Any idea?
Is it because you're wrong?
It's not because I'm wrong. Zinc should not have a Roman numeral because if you can remember, it does only have 1 charge and it is one of the exceptions. Yeah, zinc always has the same charge. It's always +2. What are all the elements? Once again, I think you've already gone over them. What are the elements that all have a 1 charge? So I heard a silver, got a zinc, cadmium, it's another one. And very more. Yeah, there's one more element, scandium. So this is plus, this is +2, these 2 are +2, and then scandium's +3. Some more trivia, some more fun facts. All right. So would y'all like to try another difficult one or more of the same thing? What's another one that y'all are like, I have no absolute clue on how to answer this? $29. Okay, we got a request for 29. Okay. So SrC2H3O2. First of all, what is this monstrosity? Is that a polyatomic ion, an element, compound? Is it there on mistake? What is it? It is right. It is acetate. So you might see it written like this, C2H3O2 minus, as a polyatomic ion, but you might also see it written like this, CH3COO minus. Both are equal ways to represent this polyatomic ion. Personally, this way is better, the CH3COO minus. I personally use that way, so it's the best. So, right, if we were to solve this out, somebody graciously told me that this polyatomic ion is indeed acetate. So to solve this out, what you do is take your strontium, because that's our metal, and then straight up pour your polyatomic ion after it. So literally, this thing is named strontium. Strontium acetate. Because acetate's your polyatomic ion, and then strontium's your metal. Metal plus non-metal ionic compound. So you just put those 2 together, and it's strontium acetate. Questions about that? We all chilling? We all good in the hood?
You should do number 32.
Number 32. We got a request for number 32. All right. Number 32. Why ClO3? Now you might be thinking, why do I care? Terrible joke. Anyway, what is this Y? Is it an element? What is this Y that I keep seeing on my page? Why am I even doing this problem? yttrium. That's how you pronounce that, by the way. Yttrium. 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 So, right, we're told that this thing has a charge of 3 plus 3. How did I get that? Because I know that this thing right here, let me do that in a different color. This thing right here has a different, is also a polyatomic ion. What polyatomic ion is this? ClO minus. Particular one y'all should be familiar with. Hypochlorite. So that's somewhere. Hypochlorite. So, right, let me just write out a name here. So we get yttrium hypochlorite.
Wait, Rish, I have a question.
Yeah.
If the 3 was for all of the ClO minus, wouldn't it have parentheses?
It would indeed have parentheses.
So in this case, I'm crossing my arms right now. Help me out.
So if you're crossing your arms right here, the ClO3, right? You gotta take into account that this is a polyatomic ion. And there's no other thing it could be, right? Because metal complexes, those are too difficult for y'all. Like y'all won't go over like naming metal complexes and stuff. Maybe in the lab, but not really here. This one in particular doesn't have parentheses. Why? Because people were stupid and they didn't add some. So mainly you should put parentheses around this because you can't have a metal and a non-metal be as a part of a covalent compound. That makes no sense. So if you were to do like yttrium monochlorine monoxide, that's not a correct name. So, right, the people who made this have an error and they forgot to put a parentheses. So this should be how it's written, YClO3. But, right, the reason why the yttrium doesn't have a subscript is because it has a 1 minus charge. So you get yttrium hypochlorite. That's the name, right? We're done. Yttrium hypochlorite. That's the name. Y'all agree with that?
Wait, okay, I'm gonna be honest. Why is it not yttrium 1 chlorate?
Yttrium 1 chlorate.
Like
Oh.
ClO3, like ClO3 minus with Y plus 1.
That's also a interesting observation, very astute observation right
Because
there.
that would explain why there's no parentheses there.
See, I was just showing you what not to do. Right. Normally, you don't assume that you made a typo in the question. You go with what the question tells you. I don't know how many times I've seen on take-home assignments people putting in parentheses. Like some of y'all deleted a whole freaking 0 on one of the take-homes, even though it's supposed to be there. So yeah, don't do what I did. Don't delete zeros. So ClO3. That's a polyatomic ion. What is that one called? Remember, it's all part of the plan. What is this polyatomic ion called? ClO3. I wonder what it is called. Chlorate. It is indeed called chlorate. And then what about our yttrium? What charge does it have now? Because there's no parentheses around here. So what's assumed to, or how many chlorines are we, chlorates are we assumed to have now that we have a 1 charge? Or how many, I'll just give away the answer. How many chlorates, my question was how many chlorates do we have if there's no parentheses, but I just said it's 1. So the name, right, would be yttrium chlorate. Y'all agree on that? That's the name? This is the correct name, how you would name this thing.
I'm gonna make up a problem right now. So what if you had a problem like Na2, sodium 2, and then MnO4?
All right, Na2MnO4. So this right would be sodium, because Na is sodium, and then this would be manganate, right? That's how you name it?
Yeah, it was more for like the students, I guess, but yeah, you got your money up too.
Oh, shoot. Okay. Okay, never mind. I thought it was mine. Okay, never mind. I was thinking something completely different. Anyway, yttrium chlorate. Is that the correct name of this compound? 100%. I'm going with chest. This is the correct name. Like if you were to see this on an exam, would you put down this?
Yes, I would.
You would put this down. That is interesting.
Wait. We're forgetting something.
We are indeed forgetting something. There we go. Thank you, Richard. We would need a Roman numeral for yttrium because it does have multiple charges. Don't agree with everything I say. It's bad. So you get yttrium 1 chlorate. That's the correct name. I was waiting for y'all to correct me on that. So this is the correct name of the compound, yttrium 1 chlorate. Even though there's a 1 there, you still have to include it, like copper 1, same thing, yttrium 1. Does that make sense to y'all? Right, I think it does. Let's go to number 35. I like this compound personally. Turns, can oxidize an alkene. It can turn a benzylic bond into carboxylic acids. It's a pretty cool compound. I want to know the name of it though. Y'all know the name? Number 35. How in the world would I name this compound? Somebody jumping it already. Potassium permanganate. Potassium permanganate. KMNO4. Manganate. All right. Is that the correct name for this compound? Type Y if you agree, L if you don't, and N if you're neutral. And N means you don't care. So glad you asked, Dylan. It adds to an alcohol with sin addition. So, or adds a diol with sin addition. So the correct answer, right, is indeed potassium permanganate. It's cool reagent you'll see in organic 1 and maybe in organic 2 if you have to take those. All right. So if there are no further questions, let's get creative. Let me create a problem for y'all. Let's do this one. Iron. So Fe3. No, wait, that's too easy. You already got that in the bag. Oh, FeCr2O7. How would y'all name that? Iron 2 dichromate. Can we get a Y if you agree, an N if you don't, and an L if you don't care, because chemistry is an L. All right, we got some Y's. L. Well, yeah, chemistry is indeed no. And you probably don't care. Learning it at like 5:51 p.m. Anyway, if we were to name this out, we would get iron, because iron is iron, Fe. That's the symbol for it. And then this Cr2O7, that's a polyatomic ion, right? Iron dichromate. And how I'm able to just list these polyatomic ions off the top of my head, I memorized them. I would make flashcards personally. I actually did make flashcards. That's how I memorized all my polyatomic ions. So make flashcards and then like just study, do practice problems. So iron dichromate. Can anybody find a problem with this name? Is that the correct name, or is there a problem with it? Yeah, you need the Roman numeral. I think on your next take-home assignment, we're required to take off some, I think it's 5 points if you don't have a Roman numeral. If you include a Roman numeral when you don't need it, or if you don't include a Roman numeral, we're required to take off 5 points. So yeah. This is iron, by the way. Good old iron ore. Shout out to all my Minecraft players. So, right, we'd have to include our Roman numeral. So iron 2 dichromate. Because that 2 is very important. Because we could be talking about iron 3 chromate. All right. Are there any questions on this? All right, let's switch it up then. Let's do this. How would you guys name this molecule? H2O. How would you name that? All right, we got some waters. What if I name it like this? Dihydrogen monoxide. That's correct, right? Because like I know my covalent compounds and I know that hydrogen, there's 2 hydrogens, so it has a prefix of di. And so we have 1 oxygen. Because this is a covalent compound, we name it dihydrogen monoxide. Why isn't that right? Let's go with the Y if dihydrogen monoxide is correct, L if you don't care, and an N if it's not correct. And then explain to me why it isn't correct. If it isn't correct. Y'all do agree with me, with chest, that water is indeed dihydrogen monoxide. Interesting. Very, very interesting. All right, so we got an I don't know. So dihydrogen monoxide, right, is basically water. That like don't name it as a dihydrogen monoxide because like the people higher up than me, whoever made this whole chemical naming scale. Oh, by the way, I hate those guys. Should probably mention. Probably every problem I've missed on an organic exam has been naming. Like all the mechanisms and stuff I got right, but it's just naming. That stuff sucks. Anyway, H2O, right? You name it as water. Why? Because the people who named this stuff, the people on the board, they said the common name for this is water. And then most of the time we'd go by the common name. So for stuff like H2O, always call it water. Don't call it dihydrogen monoxide. If you call it dihydrogen monoxide, you will get it wrong. So I'm just going to cross that out. So H2O is always water. Don't second guess yourself. Same thing with this guy, CH4. Some of y'all might be thinking, Rish, this might be carbon tetrahydride. Carbon tetrahydride. Hydride. So CH4. Carbon, 4 hydrogens. The reason why this isn't correct is because the common name for this is methane. Why? Because again, some people on the board decided that it should be methane. The board is, by the way, it's called IPAC. So if you want to change it, write a strongly worded letter to them saying otherwise. And what common names do we need to memorize? I know it's water and methane. And ozone, yeah. Those are the only ones I'm pretty sure you need to memorize. Because water is H2O, CH4 methane, and then O3 is ozone. And ammonia, yeah. NH3 ammonia. pH3 phosphine. Pretty sure that's it. Yeah, ammonia, NH3, pH3 phosphine, O3 ozone, CH4 methane, H2O water. These are all the common names you have to memorize. Just kind of box that in here. Common names. So that's why if you're doing your take home and you name NH3 nitrogen trihydride, that is why Dr. Armand will count it off. Because you're supposed to memorize that common name. You're supposed to say NH3 ammonia. Boom. Just memorize it. I also say make flashcards for this. So make polyatomic ion flashcards and common name flashcards. Use Quizlet, Anki, whatever app you so choose. And I think we have time for a couple more. So let's go with sort of a difficult one. Which one of these do y'all see is absolutely like difficult? Like if y'all saw this on a test, you would absolutely not want to see this problem at all. 76. Magnesium sulphate heptahydrate. Heptahydrate, sorry. Okay, this is actually quite an interesting one. So let's ignore this heptahydrate part for now. Y'all are going to be tested on this, by the way, naming hydrates. If you take the lab, then you'll have to name them, but for the lecture, I don't think you have to know them. So magnesium sulfate, the way how you do this is we do this like normal. So magnesium is 2 plus, sulfate, right? Your polyatomic ion is 2 minus. So you get MgSO4. But right, you have to add on something else because it says heptahydrate. You have to do times 7 H2O. That's how you name hydrate compounds. So it's the same thing. You just do your whatever it is times your 7 compounds. And because this compound is hydrated because it's like soluble or whatever, so this thing comes across with like 7 water molecules attached to it. You might ask, how does it work? The answer is, I don't remember. So you can Google it online if need be. All right. Y'all want to do more problems or are y'all tired of chemistry? You mean L if you're tired of chemistry. All right, we got a couple L's. So with that, That'll be the end of this. And oh, JK, okay. All right, that's probably it on my end. Dylan might want to say some closing remarks, but other than that, I'll let Dylan dismiss you. Technically, you can leave when you want. I don't control you.
Yeah. I just wanted to say, like, do y'all feel like this was helpful? Do y'all feel more confident in your ability to name different types of compounds if you see it on the test? Wow. Looks like I helped so many. Oh, perfect. I helped Kennedy. We helped Kennedy. Rish, we helped Kennedy. That's awesome.
Seeking validation.
Of course.
Good stuff. That's what we like to see. Helping
Anyways.
people is a good thing. It's very great.
Yeah.
Great thing.
No, we're just, yeah, of course. No, we just want to make sure that, like, if there's anything we can improve on so that y'all get a better learning experience, that would be great. But if y'all got what you wanted out of this, then we'll see y'all next time, and have a good one, and stay in your house and stay warm tonight. It's supposed to get really cold, and don't drive anywhere. Anyways, take care. Y'all have a good one.
Peace out, y'all.
Rich, are you gonna post this now or later or tomorrow?
I'll probably post it now. I got nothing else going on.
Okay. All right. Sounds good.
All right.
See you.
Peace.